So now we're going to actually solve some equations the way that you would in algebra. And part of this is for you to relearn how to solve equations, but also so that you can model it appropriately for someone if you had to teach this to someone. So, I mean, you might be teaching middle school, you might be teaching elementary school. I don't know if you're going to be teaching math, but to be able to illustrate something step by step by step, that's what teachers do. So when you solve equations, we're just going to be solving equations that have one variable. We're always going to do PEMDAS backwards. And I wish someone had told me that when I was learning to solve equations. I remember when I learned in 8th grade, Algebra 1, how to solve equations, I had a really hard time with it. And I couldn't remember, do you add and subtract first or do you multiply and divide first? And if someone had just told me to do PEMDAS backwards, I don't think I would have ever had a question. So you're actually, when you solve, you're going to do adding and subtracting, then you do any multiplication and division. So you're going to go kind of in this direction. So adding and subtracting from both sides always is the first thing you do. So we're going to work 3 problems. They all are have a little different flavor. But one thing you might want to do, and I've seen many students do this, and I think it really helps to keep you organized and neat, you might want to draw like a little vertical line down through your equal sign so you can separate the left side from the right side very easily. So we're trying to solve for x, meaning we're trying to isolate x. Right now there's a 3 in the way and there's a minus 11 in the way. And what we have to do to both sides to retain those balanced scales, right? Balanced equality there. So the first thing, if I'm trying to get rid of the 3 or the 11, you would want to do whichever one involves addition and subtraction. And so you see how the 11 is subtracted from the 3x and we're trying to isolate the x. So we want to do the opposite. We want to do the additive inverse. So what I'm going to do to both sides is I'm going to add 11. And the reason why is because then when I add them, they add up to 0. And then they're essentially gone. So the left side will just be 3x. And the right side will be 24. And now we're further trying to solve for x, so that means we want to get rid of the 3. The 3 is multiplied by the x. So the way you get rid of it, you do the inverse operation. You divide. So I'm going to divide both sides by 3, because 3 divided by 3 is 1. And so then I'm left with just a 1x, or just x, equals 8. And now I have solved the equation. And what you should always do is you should always check your answer. So plug your 8 back into the original. 3 times 8, that's 24. And you can use a calculator to help you. 3 times 8, that's 24. Minus 11, yes, it's 13. So that means we did it right. So check your answers for sure. This one, the variable was only on the left side. When we look at b, and I'm still going to write my little vertical line here, do you see how we've got variables on both sides? So we have x on the left and we have a minus x on the right. You need to collect and combine up your like terms. So you need to combine your x terms and then you can combine your constant number terms. Usually it's a pretty good practice to always move your x's so that they're sitting on the left. So this x is going to stay, and I want to move this x to come over to the other side. But do you see how it's subtracted? So to move it to the other side, we have to add it. So I'm going to add x to both sides. And if you have a negative x and you add x, you get 0 over there. But these two x's added together are going to be 2x. And then you have a plus 3 equals 2. Right, so all that's left on the right side is 2. And now we have 2 x's and a 3. From this point, it starts to look like the previous problem. So in terms of getting rid of the 2 or the 3 first, you want to do addition and subtraction first. So I'm going to get rid of my 3 by subtracting. 2 minus 3 is negative 1. And then 2 times x, to get rid of the 2, I'm going to do the opposite or the inverse. So I'm going to divide. And we get a nice little answer here of x equals negative 1/2. And again, you should totally check your answers, right? Negative 1/2 plus 3 would be 2.5. Wait, no. Negative 1/2 plus 3. And then 2 minus negative a half, yeah, that's 2.5. 2 minus negative a half is 2 plus a half, which is 2.5. Sorry, I questioned myself there for a second. Sorry for the long pause. But yeah, it does work. This is actually the correct answer. So the last one that we're going to see here, you can see it's a little bit more complicated, and it does have parentheses in it. And with PEMDAS, you always start with parentheses, and actually when you're solving, you don't want to have any parentheses. So the way that we get rid of the parentheses is by distributing. So we're actually going to distribute on both sides. The left side, we need to distribute that 3. See how it's multiplied into this subtraction? And then we're going to need to distribute the 5 over on the other side. And this is going to clear out the parentheses so that this looks a little simpler. We won't have parentheses. So 3 times x will be 3x. And then 3 times negative 3 will be a minus 9. Over here on the right, we'll have 5x. And then minus 15. And now it kind of looks like the previous problem where we've got x's on both sides. I always think it's a good idea to move your x's to the left side. So I'm going to move my 5x over. It's positive. So I'm going to subtract it. And if I have 3 x's and I take away 5 of them, I'm going to be left with a negative 2x. And don't try to do too much in any one step. Like, try to be neat and organized so you can read your own writing. So now I have negative 2x minus 9 equals negative 15. Okay, so I'm trying to isolate the x. I'm going to get rid of this minus 9 first. I'm going to add it because that's what would give me 0 on the left side. So then I have negative 2x on the left side. And negative 15, if you add 9, you get negative 6. And then my last step is going to be to divide both sides by negative 2. Because negative 2 divided by negative 2 is 1. So we'll just get x. And over here, negative 6 divided by negative 2 is going to be 3. Let's check our answers. If we plug in a 3 right here, 3 minus 3 is 0. So 3 times 0, the whole left side turns into 0. On the right side, 3 minus 3 is 0. The right side is going to turn into 0. So since the left and the right sides are equal when we plug in this number, that means we have found a solution.